Oh, hello. Welcome to my presentation. Just in case you're wondering, this is not the low latency talk. I talked to you about Slint today, which is a UI toolkit. And I will try to build an to-do editing application together with you from scratch today. I do want to deviate a bit from the normal pattern we have here, so please just ask questions whenever you have any, because I will do a lot of coding, and it's really hard to go back to something you did, like, can you go explain what you did 10 minutes ago? That's just not going to work, so please just ask. If you ask a question, please try to remind me to repeat the question so it's on the recording, because I will probably forget it. So let's get started. My name is Tobias. I'm a software engineer at the company that works on Slint, 60 FPS GmbH. We are located in Berlin. I have a background in C++. I've done that for a couple of decades. I'm old. In the last 5 years, I've been doing mostly Rust development, full-time in a professional capacity. It's real great. I also do a bit of Python and a bit of shell scripting, whatever comes up, the usual thing that what you do as a developer. And during my career, I've mostly worked on tooling. So tooling for C++ developers, so IDEs, build systems, build tools, linters, whatever. And that's what I'm still doing today. I'm responsible for the tooling that we have in Slint and try to make that as good as we can. So what is Slint? Obligatory slide. Everybody needs to have that in their slide deck. So Slint is a UI toolkit written in Rust. I already said that. We claim that we are scalable. So we want to have a UI toolkit that works on embedded devices, microcontrollers, and all the way up to developer workstations with graphics acceleration, whatever is there. We say we are lightweight. So we have demos running on microcontrollers with about 300 kilobytes of RAM, where we actually don't have enough space to have a full frame buffer, so we render one line at a time and push a line into the screen, and at that time we render the next line. Of course, we also support frame buffers, we support graphics accelerator cards, whatever you need. And we're native, so there's no web runtime, nothing. It's just binary code that we produce. A word about licensing, because that's always coming up. We are an open source project, so we are GPL licensed version 3, which basically means you're free to use it for whichever project, but you're expected to share your code with your customers as well. We also have a commercial license option, so if you're interested in getting support and just get rid of the GPL requirements, then that's something we can discuss. And there's, in addition, a royalty-free option, which is basically you're free to do software, whatever it is, on mobile and desktop devices, but you're not allowed to do the same on embedded with that license. So if you want to do a UI toolkit for desktop systems, feel free. Royalty-free license has you covered. And so this is a couple of projects, so just to get you to give an idea what you can do. So up here we have a electrical charging solution by one of our customers. It's a huge screen, fancy animation, very fluid. And up here in the corner is a different example. That's actually a Raspberry Pi microcontroller running a little demo. That is a device with 200 kilobytes RAM. This example here is wonderful because it shows how you can embed Slint UIs into software. So that's actually a plugin into a digital audio workstation. And the plugin has its own UI written in Slint with fancy animations and stuff. And we have a little desktop application just to give you an idea. So, and now back to coding. So any questions so far? So if not, then we go here and we start by having no internet. So what I wanted to show here is we have in our doc section, we have project templates. So you can use that to start out with. And I'm not depending on it. So in preparation, I already checked that out. So I have it here locally. I just wanted to show that how you actually get that on the system. There's a tool called cargo generate, which helps you with that. So you can just do cargo generate, point it at some Git repository, and it will do the magic for you. So let's do just a cargo run. Oh, is the font big enough? Can you read? Everybody read that? Perfect. Oh, let me try to do that. How do I do that with this tool here? Is that okay? So just a cargo run. This is what you get out of the box with this template. It's just a little text field with a counter and a button. If you click it, counter goes up. So basically the hello world of GUI programming. So let's take a look how that works. This is Visual Studio Code in default installation. Nothing changed out of the box as is. So you see that with this wonderful, yes, I trust the authors. Let's do a light thing. And where's the size? Zoom in. Control-Shift-0. Is that big enough? So what should happen is it should actually pop up some notification. Oh, apparently it takes a while. Let's start with cargo toml. And that's the first thing I would like to change to do UI. So in here, there should be really nothing that's surprising to anybody. It's just a dependency on Slint. Currently, we are at version 1.8. We had the stable 1.0 release a while ago and have been doing steady updates ever since then. We have a stable ABI. We have customers that depend on us having a stable ABI, so we take that really serious. And we have another build time dependency on Slint build, which helps us, which we'll get to later. So I'm surprised. So normally there should actually pop up something about recommended. Oh, I'm offline, so that's the problem.
You want the password for the Wi-Fi?
That would probably help.
You have the Wi-Fi disabled, so
yeah.
maybe that's the problem.
No, that's not a problem because I've not connected it.
Yeah.
Is this one?
Yeah, it's Florence with the uppercase F, 2024.
Let's see whether that works. It's amazing how these tools are online all the time and you don't realize it till you sit in a... So let's try that again. Or whether that works. No. Because I actually need... here it is. So the plugin is, this project template is configured to actually install some or recommend some plugins to Visual Studio Code. One of them is our Slint plugin, which helps with the graphical parts of the development. But it also includes a couple of Rust Analyzer and generic Rust things. So now that the Slint plugin is finally there, let's go back and check out the UI code. So that's here in UI. And at this point, I usually get the first, what? You said it's native. That's not looking like native Rust code. And indeed, it's not. So we decided to have our own language to describe the UI with. And that gives us a couple of advantages. The biggest one for me personally is as a Rust developer, I'm not required to actually code a Rust UI. So in a typical environment, when you have the UI description or as part of the programming language, you often end up in a situation where you have some design team that walks up to you, this is the design, implement this. So you get a wonderful screenshot and you just copy and paste and measure and move things around. And it's terribly fiddly work. It usually takes me 1 or 2 weeks to get it done. And then I go back to my designer. Here, I implemented your vision. And he goes, that's not the right color. And the spacing here, that's totally off. So with having a separate language, we actually allow designers to do their job without depending on Rust developers, and Rust developers to do their job without risking the design work. So I think that's one of the biggest advantages this has. There's another advantage. We can use concepts very easily which are not available in Rust. For example, we have inheritance here. So we have an application window which inherits a window. So that's something that would be hard to express in native Rust code. And it's a tree structure of widgets that can also be tricky and require some jumping through hoops sometimes. And finally, we have a third advantage, in my opinion, and that is we have a very strict separation of business logic and UI. So the only thing that's actually exposed to the business logic is this part here. So we export something called application window, which is something we can instantiate in the Rust code later. And we have an in-out property for the counter value. So in-out means we can read, and we have a getter and a setter exposed to Rust. And we have a callback or request increase value. Everything else is considered internal, and this allows us to do a lot of optimizations because there's no way somebody finds some tricks to go around the description and grab some Rust object down here and pull it out and modify it in some way that we don't know about. And this is actually part of why we can go down to such low-level hardware, because we know what a developer can manipulate, we know what's constant, or we know if you have some property that's never changed, we can just replace it with a constant value in the code we generate, so that we can get rid of all these the additional logic required to make this modifiable and signal something and signal some change so that something else can react to that change down here. It's never going to change anyway. We know that, so we can just cut out the whole thing. And apart from that, it's actually quite simple. So we have a lot of customers where the project starts out with a typical designer, hence design to developer, developer does Slint code. And a couple of weeks later, the design team goes, wait a minute, we can do that. And that's a way more satisfying experience for everybody involved, because the designer can do their stuff, the developers can do their stuff, and everything is fine. And one more advantage that we have here is we have a very limited interface area that we expose. This actually enables us to do a couple of things. So depending on what your target environment is, we can generate different code. So we can generate code that is ready to be run in an interpreter, which helps with the tooling. We will show that later. Or we can compile it down to native Rust code and embed that in an application. Or we can take the same code and compile it into C++ code and enable you to have a business logic in C++, which is interesting for some customers because they have a huge C++ code base and they want to eventually end up in Rust, but they're not there yet. So they can start with C++ business logic or use whatever they have right now and then slowly migrate over to a Rust-only world. And finally, if that's something that's really great for prototyping, we can also generate bindings for JavaScript code or Python code. So you can have your business logic in JavaScript or Python or TypeScript or whatever, which is also really convenient. Are there any questions for this the UI description code? I mean, it's just a vertical box here. So we have elements that are on top of each other. We have the text with the counter that you saw, the counter value here, which is this one here. And we have a button which, whenever clicked, runs the request increase value thing in the business logic. It's not rocket science, I guess. Yes?
Where does the window come from?
The window is actually a data type we have built in, so you don't need to import it. So the button and the widget box is actually a more complex thing that we provide for you in the standard widgets. but we also have a couple of really primitive things like a window, a rectangle, a touch area that are actually built into the language and are available everywhere. Yes?
Yeah, I see you call there is a callback, so I imagine that in the backend you are retrieving the counter, increasing and resetting.
Yeah.
Because it's out.
We move over. That's the next thing I'll show you.
Can you do that directly from the, let's call it at the template, or you are forced to pass by the backend?
You're required to go through the backend. So there you can do a couple of simple things, but this is not meant to be a Turing-complete language. So it's not meant for you to implement anything business logic related in. So we really want to stress that you have a separation between logic things. I mean, for the counter, I mean, that's pretty primitive. But in general, we really want you to have the business logic on one side and the UI on the other one. So let's move on. So I said it's native, and what you saw was all native code. So how do we get from here to native code? And that's build a REST file here, which are you familiar with build a REST? So in the end, it's a Java, why Java? A Rust file, which Cargo builds as part of its own build process, and then it runs it. It can produce extra code or do whatever you can express in Rust code. And what it does here, it just runs the Slint build crates that we also included as a development dependency, and compiles the Slint file and then expects build has failed. Okay. So this translates the Slint file into Rust code. And this Rust code then ends up in this macro here in the main RS file that includes this generated Rust code and makes it available to the to the Rust module it's in. You can also do something else. So you can actually do use a Slint macro and then do export component, let's say text. So you can also do this if you want to do that, but this requires you to actually stay within the Rust language tokenizer rules. So it sometimes is a bit fiddly to get that right, especially when you have strings with weird escape sequence in them. So the recommended way, or the way I would recommend doing it, is really to have a separate Slint file and a include modules thing. And so now we are back to what you already suggested. So we create a new app instance of the app window. We define the on-request value callback, which just keeps the handle to the UI round, so it actually can go and upgrade the handle from a weak handle, and then it just gets a counter and sets a counter. So just like as you said it would happen. There's no surprise here apparently. So, any questions so far? Yes?
I see you asked me, is that because it's not an arc, the UI?
The UI is, I think it's an arc. It is an RC, so we require you to run it, to have everything in Slint in one thread. So with all the callbacks, and you need to have a weak pointer so actually can upgrade it later. So otherwise you get to the typical problems with having multiple strong references. So let's try to do some to-do application. So for that, we obviously don't need this callback and this property here anymore, and we also don't need the callback. Let's keep that for now. We can just use a live preview, which is a nifty little tool I'm very proud of. So this just shows you the UI as you have it in your code there. Can I make a bit more space here? So if you go in here, you can change it and it updates. Or you can see where your code is in the UI. So that's a vertical box that is. And you can also do it the other way around if you go into edit mode, which is a bit big for this screen. So I can go in here and let's just delete this stuff. We won't need that. So for a to-do list, we need a list of to-do items, obviously. So let's get started with that. We can go down here, standard list view. We just drop it here. We have standard list view, and we can just do model. Model is a list of things, and the standard list view is pretty simple. It just has a text, ABC, and text DEF. And I need a semicolon here. And actually, this is a bit small. I just force it to be bigger. Let's say 300 pixel times. I mean, you would probably not want to hard code that in a real application, but for this demo, I hope you don't mind too much. And generally, you would want something more reactive, so where you can actually drag it and rearrange layouts depending on how you actually want to have it. So this part here is no longer needed. We can get rid of this. But now we have something in the list that's pretty boring. We want to be able to set it from the outside. So we need a property to actually do that. So we do in property, and we want a list, and we want to do items. To do item, let's say, and then let's call that to-dos. We need to define a struct. It's not, I guess that's not surprising. We just want to have a text, a string, and a checked, so that you can mark them as done, which is a bool. So now we can set the to-dos from outside, and here we want to have a bit more control than we have with a standard list view. So we go for a custom one. We probably don't need this one here anymore. And here we can just, let's go up, where's our to-dos? We can just loop over our to-dos. To-do in the root element has a to-dos. And here we want to do, let's say, a checkbox or with a text. Do I need to import that? Yep, I need to import that, sorry. To do text and checked, to do checked.
So is this Slint syntax that just happens to look the same as RustLab?
Yep, that's all Slint files. So it's all Slint syntax so far. So this is basically what we do on the UI side so far. So now we need to have a business logic. So this entire stuff here is obviously no longer working because we removed it. So any more questions?
This struct also appears in the Rust part. Now I didn't want to do jobs.
Yep, it does. So we generate code for everything that's exported, and this property is exported, so the types are exported as well. So here we can just go say we want to have a model, which is a RC new because we will want to share it later. And we just use a Slint vec model because that's simple enough. And here we do a vec, we do a to-do item with a text. A, B, C, D, E, F, G, H, I, into, and a checked. Obviously, that's false. Let's duplicate that so we have at least two items so that we can see something. So the RC needs to be imported, I guess. How do I trigger these?
Control space.
Yep, thank you. Yeah, so this works here now. And nothing is red anymore, so that part apparently works. And now we can just go and do UI set to-dos for that. Let's try what happens when we try to run that. This is always the most exciting moment in the presentation for me. Yes?
Can I derive stuff to the to-do item structure, or is more like a DTO?
It's a data type, yeah. So it's really just a descriptor, convenient way to group data that goes together, like a struct and C++ would be. Oh, what did it do? Package, Slint, Rust template, not found. What's wrong there?
Because it's running package Slint Rust template.
Did I not save this one here?
I think in the old one.
Ha! It was just that. So it helps to actually save your changes. Who would have guessed that? I mean, that looks a bit cramped together, so we can just go in here and wrap this. Let's put this into a vertical layout with some padding. And now it's a bit unfortunate because we can't really use live preview at the moment because the business logic is not evaluated in the live logic. So I actually have to rerun it now. Yep, so a bit more spacing, so that makes designers always happy in my experience.
Shouldn't the vertical layout be outside the form?
I could do that as well, but there is already a layout in the list view. So I just wanted to add some spacing to the individual elements. I could also place a rectangle that's a bit bigger and stuff. So there are different options for that. Yes?
Can I initialize variable in the Slint file?
No, you just can have properties and elements. That's all there is. Yeah, more questions?
How did you build the preview?
That's built in, that's basically Rust code that we have written for you. So you can also build, I will show you later how to build your own components. But for now, that's just code that we have provided, and that's built into the Slint language itself, or into our widget set. Okay, so we obviously need, we now can show to-do items. We obviously need a way to add to-do items because otherwise it's not much of a list thing. So let's go back in here. Let's go back to the preview. For adding new to-do items, I want to have a way to enter a new text and a button to edit. So let's do that. So let's start with a, where is it? Up here, the horizontal layout. I'll just drop it in here. Where's my button? Let's put a button here. And where's my line edit? Let's put it to the front of this one here. Oops, that was wrong. I want it here. Now I can just, and now we need to tweak this a bit. So we can go into the layout and adjust the spacing so that we have a bit of space in here, or a bit of space here. And then I can go to the button. Come on here. And the text button is not really good for what we do. Let's change that to add. I don't want to have the text line edit. I just want the placeholder text to do. So with that, I'm quite happy with the UI. So let's check how that looks like. So we have the line edit here. We have the placeholder text, the empty text. We have the add button. So we need to have a way to call back into our business logic that we have a new to-do item. And we need to provide it with a string for the text. So let's define a new callback. And in the add button, we just want, whenever that's clicked, we want to go in and just to call root add to do. And we need a string to put in here. And for that, we just can name this line edit to, I'm very poor at naming, I just go LE for now. And now we can go to LE dot and get the text property from here. And if we go back to here and, well, that's actually something we can test here. So now we can't test here, we really need to implement the business logic for that. So we need to implement the callback we just defined. So UI on add to do, we get a string in. That's wrong. This is wrong. And now we just want to add it into the model. So model push to do item text is S. Checked is obviously false because we and now this is complaining because we only have one. We have the model up here, and here we need to pass it into that closure. So, and we also need it down here in this area. So we need to clone that. Otherwise, Rust will not be happy with us. So let's try to run that. Let's see whether that works.
You have an error. You have probably got move to the closure.
You're right, I need to add move to the closure, and that's already highlighted here. The Rust developer experience is sometimes really great, so I love the Rust analyzer. So we have our text here, we can enter new test thing, we can click, we can call back into business logic, it adds that thing, and we're done. So you probably also want to go in here and reset the text here, but that's Polish. I leave that as an exercise to the reader. So that's how far I would like to go with that application. The next thing is you have something that works, and at that point somebody comes out of the background and says, yeah, but our company colors are red and blue. We need the button to be red and blue. So what do you do now? Our button up here is obviously not red and blue, so we need to do our own component here. So let's get rid of the button and do our own. And if you go down here, you will notice a button has a text and it has a clicked thing, so we need to implement those. We have a property which takes input, is of type string, so everything in the Slint language is fully typed. we need to call the text, and we have a callback clicked. So if we go down now, it's happy. Oh, it's wrong here. Where is it? This part here is happy, so it can set a text, and it can set a. There is a callback called click, so everything is fine. Or if you look at it in the live preview, it's not really working because the button doesn't do anything. It's just an empty component which doesn't show anything. So for that to be useful, we actually need to add some more elements. Minimum thing we need is obviously a text. That text has a text field, which is this root component, so this button here, text, and we want a touch area. These are all also built-in elements, so you don't need to import them. And if that is clicked, we want to trigger root.clicked. So if we go back to the live preview, we have a text now, and we can click it, which you don't really see right now, but if we actually build it again, so our button should work, even though it doesn't really look much like a button. So if I go type test here and click it, it works as a button, it just doesn't look like one. So how can we make it look like one? The most primitive thing I can think of is we put a rectangle in the background. And we make the background is company colors were red and blue, so obviously it must be red. If you go back to the show preview, which is for this button component, that was a preview for the button component, we want the entire thing. Now we have a red button. We can go and name the touch area. Also, very innovative naming scheme for touch areas. And we can go, if the touch area is pressed, then we want to have blue and otherwise red. Where's the live preview? Did I close that? So I need to go to interactive mode. So if I click here, it's blue and red. And obviously, we also need to animate things. So if we go up here, we can do animate background. So this will trigger whenever the background changes, and we'll do, let's say, put a duration, 300 milliseconds, and we want to ease in. It's nice. So if we preview that, and we click, then you have an animation going there. And that's basically as far as my design skills go.
A little bit of padding, maybe. A little bit of padding.
That would help, yeah. But I can show you what people with design skills can actually do with that. Yeah.
Would I be expecting that the text will go inside the rectangle? Is it because it doesn't have a layout, so it puts everything together?
So by default, if there's no layout, it will just put everything in the middle of the parent element. So these are 3 items.
But would it work also putting the text inside the rectangle?
Yes.
Okay.
You can also, yeah.
Can you extend the button directly to create the whole button?
Yeah, of course. I can inherit from the old button.
Other properties, and you don't need to add the text.
Yeah. So this is another tool we have. It's basically a website where you can just go and play with the Slint code. And this is what people with design skills can actually do with the animations and stuff here. So that's far beyond what I can do, so sorry for that. Or you can also do fancy buttons like these here. So if you're able to do that, I am definitely not. So, any questions so far? It was faster than I expected. Yeah, there's one in the back.
Yeah, sorry, how would you implement the state change of the individual items if you click the checkbox?
Well, you can actually do that. So we have a state expression where you can actually define different states and when they are entered, and then basically group properties together there that will change or that will be set as soon as you enter that stage and will be set to the next state.
It's on the screen right now.
Yep, here you see it. So also lights is off when not root light on and stuff like that. That's how you would implement states. So if there's no more question about that stuff, then we can do a bit of async programming if you are up to for that. Any tests? No more questions. Okay, then let's do something else. So for that, so typically you will have your to-do items in a database, obviously, because we need to be cloud scale and enterprise ready. I'm not going to implement a database. I'm not that crazy. So how would we do that? So let's assume first thing, so I don't want to do a database, so I just go with a timer. So I just do cargo at small, which is a small runtime environment, which doesn't take too long to build here. And then we can go back. And we do an async function here. Get to-dos. And that just returns a vector of to-do item. I just grab it from down here because I'm lazy. And this one here needs to be a default then. And up here we do a bit of a delay. Well, that's small timer after duration from. Let's say we wait for 2 seconds, and then we return that to-do item. Yep, I need to await that. Thank you. Live coding is always harder than it looks, I can assure you. So we have our model here now. We set a model. The model is empty now, so if we just run that, we are not using our get-to-do items yet, so we see an empty list after small is done building. So nothing to see as expected. So we can now go in here and ask, we will need the model again. We can ask Slint spawn local. So we can ask Slint to actually run a future inside its own event loop. So we can just do async move and have a block of code. Model set vec is get to-dos.await. you shouldn't unwrap. I hope you're aware of that. I'm doing it here anyway. So now let's run it again. So, and after 2 seconds, ta-da, things show up. We can go a bit further if you want to, or we can just show. You can just add a spinner because it's ugly to leave a user waiting for seconds. Where is the preview? Here is a preview. I want to edit again. And we have a spinner down here. Let's put it at the bottom. The spinner is supposed to run indeterminate, so it just spins. And now I can show you something else. We can do an if condition. So we need to tell the window that it's loading. Property bool is loading. Yep, thank you. I really appreciate your help here. Now I have another typo. So while we are loading, we will just show a spinner. So in our business logic, obviously down here, we must tell it we are loading. True. And here we need to tell it that we are no longer loading. So as weak. So it's our UI that is loading false. Yep, that's what I wanted to write. You're really great help. I really appreciate it.
Typo. Because I use it with my junior, so I'm not telling you I are.
Oh, I definitely feel like one right now.
Who wasn't?
Restart. So let's try again. So it's running the spinner, and after 2 seconds, we're done. So that's basically all I wanted to show to you today.
Is there a way to put a sync code inside a button click? Can I add a sync code in a button click?
You can bind a button click to the business logic which runs an async sync, yes.
Always with spawn local?
With spawn local, yeah.
Okay. So I'm forced to run the sync inside the local.
You can also use Tokyo, for example, but then you need to basically run the Tokyo engine in a different thread from the UI.
And communicate with channels.
Channels, or there's a thing called invoke from event loop, which will just add a callback into the next time the event loop is run. So that's basically it. It puts it in the event loop. The event loop is always run in the UI thread, and the next time it's triggered, it will execute your code, and then you can continue.
Being a sync should not block the UI.
Yes, okay. That's the idea behind it. Any more questions? Yes, there's one in the back.
What is exactly inherited when you inherit a component?
So property and the callback. So everything that's defined in this in the type here. Excuse me?
The layout needs to be redefined.
You can redefine your own layout. Yes.
Okay.
So you can. So we have a horizontal and vertical layout and a grid layout, which is really just putting things. So you can have spacing, you have padding, everything you need. but by default, everything is 0. So it's just everything there. And then we have a layout box which inherits from the equivalent layout, which adds default paddings depending on the style you're running in. So it will be different on a Mac, on a Windows machine, whatever.
To be clear, if I inherited the base button to create my custom button,
Yep.
I would need to redefine the text.
If you inherit the base button, you have the text property, which you can just set, and it will be used as is in the base button. So you get basically the entire thing, not just. So you really need, if you don't want to have our styling, you really need to do it basically from scratch right now, which is not ideal. I admit that. Yeah, one more question there.
In your async example, what's about error handling there? I mean, assuming this is a network thing, can return some errors.
Yep, you can return a result. So the thing itself returns a result with containing the types that your code returned.
Yeah.
So you can use that for error reporting.
So basically, I can return the result to Slint, or I need to do my own error reporting there. And
Well, the result goes back to wherever you called your spawn local from.
in that example, you just passed the future to Slint. So
yeah.
the question is, how would it work there?
Well, so in my example, it was really simple. So I just had the main function and I did the spawn local there. But the spawn local itself will return a result containing your type in the OK case or the error case.
I could check there and say, okay, if it's an error, something else displays some notification, it's broken.
Yep.
Okay.
Are we out of time?
Yeah.
Oh, perfect.
Okay.
So thank you for your attention. I hope you took something out of this. Enjoy the conference.